Hello, good evening everyone. Welcome to BYJU'S Exam Prep. Yeah, so audio and video are absolutely fine. Yes, so guys, quickly share the session with all of your friends because here we are going to discuss the ISC previous year questions from the subject communication. Okay? Yes, guys, so quickly share the session with all of your friends and comment in the comment section if you are already live. Comment in the comment section if you are already live. Yes. So guys, today we are going to discuss the questions of communication system and this all communication questions I am bringing in the two parts. ठीक है 2002 2008 और 2016 के क्वेश्चंस हम लोग कवर करेंगे जिसमें हम लोग इसको दो पार्ट में डिवाइड किए हैं इस पूरे सीरीज को सब्जेक्ट को है ना एक पार्ट वन आज होगा पार्ट टू नेक्स्ट क्लास यानी कल होगा ठीक है तो ये दो सेशन में हम लोग आईआईएससी बैंगलोर के प्रीवियस ईयर क्वेश्चंस आज के सॉल्व करेंगे. So before starting the session, let me introduce myself. So this is Saket Verma, and I have done MTech from IIT Guwahati, and I cracked many different PSU exams. So out of which, in some are which are standard actually, Airport Authority of India, DRDO, and Bharat Electronics Limited. I have mentored more than lakhs of students online and offline, and my area of expertise are electromagnetic theory, communication system, advanced communication, signals and system, etc. So these are my area of expertise. So you can join my Telegram group also to have this PDF. I will share the PDF of this class in the group in the following group. The group name is Electronic by Saket Verma, and the link is http://t.me study with Saket Verma. सो यूपीएससी डबल ई 203 का जो रिजल्ट है वो आउट हो चुका है आप सभी को पता है ना और फ्री मॉक इंटरव्यू अगर आप देख रहे हो ठीक है क्योंकि आपको लग रहा होगा कि कुछ क्वेश्चंस आपको किस टाइप के क्वेश्चन पूछे जाते हैं कैसा एनवायरनमेंट रहता है तो इस चीज के लिए आप हमारा पैनल ज्वाइन कर सकते हो और उसके लिए आपको लिंक गिवन है डिस्क्रिप्शन में सो गाइस दिस इज द फर्स्ट क्वेश्चन एंड आई एम गिविंग यू बिकॉज दिस इज अ गेट क्वेश्चन ओके आई थिंक ओके नाउ लेट्स switch on the timer. So you have 3 minutes to solve. You have 55 seconds now. Okay. So how many of you have solved this problem? What are the answer you are getting? Okay. So I think nobody could solve this question. So in this question, it is given that if the variance sigma d square of d of n is equal to sigma x of n minus x of n minus 1 is 1/10. X of n minus x of n minus 1 is 1/10 of the variance sigma x of the stationary zero mean discrete time signal x of n. Then the normalized autocorrelation Rx divided by sigma x square at k equal to 1. So we have a random process which is given by x of n minus x of n minus 1. Okay, this is the random process which is given. And also that sigma d square is equal to sigma x square divided by 10. Okay, this is the value which is given to us. Now, if you want to calculate the variance of D, so what is the formula for the variance? The variance of any random process or random variable, in fact, this is the mean square value. Okay, this is the mean square value. This is what? Mean square value minus mean whole square. So this is the formula we have. Okay, this is the formula which you have. Now to calculate the mean square value or mean value of d of n, we will write expected value of d, that is the mean, is expected value of x of n minus x of n minus 1. So this is expected value of x of n minus expected value of x of n minus 1. So what is the mean value of x of n? So here it is given that the x of n is having the stationary and zero mean discrete time signal. So it is zero mean and stationary. That means with respect to time, its PDF will not change. Hence, the mean and mean square value will also not change. Now, expected value of d square n, that is the mean square value of this, is x of n minus x of n minus 1 whole square. So this is a square plus b square minus 2ab. Okay, so this is expected value of x square n and expected value of x square n minus 1 minus 2 into expected value of x of n into x of n minus 1. Okay, so this is what we are getting. Now, this is the mean square value, and how can we calculate the mean square value? Mean square value can be calculated as the autocorrelation at 0. So autocorrelation at 0. Okay, but this is the autocorrelation of x, na? This is the autocorrelation of x. So Rx 0 plus Rx 0. This is also because it is stationary, so it will not change with time. Minus 2 into Rx of 1. Okay. Now because the mean is 0 from here, if any random variable has 0 mean, then the mean square value and the variance are same. So this is sigma d square equal to 2 times Rx of 0 minus 2 times Rx of 1. Now, what will be the mean square value of x? So mean square value of x is also mean square value of x if I want to calculate. So the mean square value is autocorrelation at 0, we are saying, right? Now after this, what will you do? Come on. So this is now sigma x square upon 10. Sigma x square upon 10. This is the autocorrelation which is already given. So 2 times Rx of 0 minus 2 times Rx of 1. This is also the mean square value, and because we want to relate in the mean square value of x, this is the mean square value of d in terms of x. So mean is 0, so it can also be written as mean square value of x. Okay, it can also be written as mean square value of x. Since it is or mean square value, Rx0 is mean square value, and mean square value, if the mean is 0, the mean square value become variance, that is sigma x square. So now it is 2 times Rx of 1, or you can say if I take the 2 common, then I will get Rx of 1 is equal to sigma x square divided by 20. This is in minus and plus sigma x square. So it is Rx of 1 divided by sigma x square is equal to 19 upon 20. So 19 upon 20 is 0.95. So how much we will get? 0.95. So is there any option? 0.95? Yes. So correct answer should be option A. 0.95 is the right answer for this question. Okay, next. Solve this one. By logic, you can solve it easily. And if you want to solve it mathematically, then also you can do. Okay, solve it. Solve it. I'm doing some rough work. Okay, so what is the answer you are getting? Okay, so guys, the answer of this question is this is the integration of the PDF, and because we want to calculate the CDF, so we should know that the CDF is nothing but the integration from minus infinite to x and then f of lambda d lambda means the integration of PDF. So you have to integrate this triangular signal which is given to you. Okay, it is from minus 1 to 1. This is the PDF given to you. Now, if suppose I take the first case, the case number 1, that if the x is in between minus 1 to 0, in between minus 1 to 0, then in that case the CDF would be minus infinity to x. That is the signal because it in the range of the limit will become minus 1 to x, okay, and here it is x plus 1 d lambda. You can write lambda instead of x. Now when you will solve it, you will get lambda square plus divide by 2 and plus lambda, limit from minus 1 to x. So here you will get x square divided by 2 plus x minus of 1 by 2 minus 1. So finally you will get x square by 2 plus x, and this is plus 1 by 2. This is the first case. Now coming to the second case, case number 2, when suppose your x is in between 0 to 1, then f of x is equal to 0 to x, 0 to x, lambda plus 1. Here it was minus lambda plus 1, d lambda. So minus lambda square divided by 2 plus lambda. Limit will be from 0 to x. Because it is in between, sorry, there is one more limit also. 0 to x, and also there will be one more term. Let me write that also. Let's write it from the beginning. The limit will be from minus 1 to 0. This is lambda plus 1 d lambda, and 0 to x minus lambda plus 1 d lambda. So the value of this integration, first integration is 1 by 2 because it is denoting the area under the PDF. So area under the PDF gives the probability, and half of the probability is 1 by 2 because it is symmetrical about origin. Then minus lambda square by 2 plus lambda, limit from 0 to x. Now it is 1 by 2 plus minus x square by 2 plus x. This is what you are getting. So from here you can see, and if I suppose take the case number 3, the x greater than 1, then if you choose x greater than 1, then fx of x from minus 1 to 1, this is the f of x dx, that is the PDF, and its area will be 1. Hence, if you will draw it, okay, if you will draw it, you will get this type of function. Okay, you will get this type of function like this. So at x equal to 0, at x equal to 0, it is 1 by 2, it is 0.5, and here it is 0, and here it is 1. At infinity, it is 1. Coming to the next question. So solve this question. So answer you have got, right? Answer is option A. Answer is option A. Now answer this one. Yes. Now what is the answer you are getting? So as you can see in this question, the probability density function is given for any random variable, and over the entire x-axis m and n are positive real numbers. The equation relating to the m and n expected is expected value of x. What is the relation? M and n is expected. What is the relation between m and n is expected? So first of all, to solve this problem, you should know that according to the property of the PDF, the total area under the probability density function is unity. Okay, so total area is unity. Now, how do you calculate the total area? To calculate the total area, you will integrate the probability density function. And what is the function? The function is given as minus infinity to 0, it is positive. The exponential will be negative. So m e to the power 2x, m e to the power 2x plus n into e to the power 3x dx equal to 1. So this is m by 2 e to the power 2x plus n by 3 e to the power 3x. This is between one more thing which we are left with from the positive value 0 to infinity. This is m e to the power minus 2x plus n e to the power minus 3x dx equals 1. So plus m e to the power minus 2x upon 2 plus n into e to the minus 2, in fact, minus 3x upon minus. Limit is from 0 to infinite for this, and minus infinity is 0 for this. So from when you put the limit as 0, you will get n by 2, n by 3, and when you put infinity, it will be 0. Now in the second term, the minus sign is there, and when you put infinity, it will be 0. When you put 0, you will get minus m upon 2 minus n upon 3. So this will become m by 2 plus m by 2 plus n by 3 plus n by 3 equals 1. So when you will solve it, you will get m plus 2n upon 3 equals 1. So this is the value which we are getting. Okay. So it means that our correct answer would be option A. Our correct answer would be option A. Now answer this question. Yes, last 1 minute. Quickly solve. This is a good question. Consider a random process x of t equal to 3vt minus 8, where v of t is a zero mean stationary random process with the autocorrelation rv tau equal to 4 e to the power minus 5 mod tau. The power in x of t is. Last 20 seconds. Consider a random process x of t equal to 3vt minus 8 where vt is a zero mean stationary random process. 100 you are getting, Bhanu. Okay. So the power in x of t, the power in x of t, the power in any random process can be called as a mean square value. So the mean square value is expected value of x square t. Okay, so this is expected value of x square. X square is 3vt minus 8 whole square. So it is 3 into a square, that means 9v square t minus 48vt plus 64. Okay, now if you will calculate it, 9 into expected value of v square t minus 48 expected value of vt and plus expected value of 64. mean square value of v, mean square value of v, because the v has zero mean, and mean square value we can calculate it at tau equal to 0, so that is 4. So 9 into 4 minus 48 into 0, because the mean is 0, and the constant has the mean 64, that is the mean, constant mean is constant itself, so we are getting 100. So the right answer for this will be 100, correct. Now answer this question, Manu, quickly. Okay guys, so if you are not able to see the question, then let me hide myself. This is the question guys, so I think now you are able to see this. Okay, now according to this there is a xt, and in the upper part there is only plus sign and no gain, and in the second case we have the delay. Okay, now I think you have already seen the that question, so now there is no need to remove them. Yes, so there is a delay of t naught, and in the upper part we have 1. There is a delay of divided square divided by 2 plus. Okay guys, so if you are not able to see the question, okay, as you saw that we have upper path and we have the lower path. Okay, so according to this, if I write if I write this particular, yes, b you are getting, na? So in the upper part xt, and here the delayed version. So actually we are getting the y of t is equal to xt from the upper path, and it is subtraction in the lower path after delaying. So this is the process which we are getting. Now we want to calculate the autocorrelation of ry. So ry tau, that is expected value of yt and yt plus tau. Xt plus tau minus xt plus tau minus t naught. So we will get expected value xt and xt will be multiplied. So we will get xt into xt plus tau. Then it is multiplied with this x of t and x of t plus tau minus t naught. And it is multiplied with this. So this is x of t minus t naught and x of t plus t naught tau. And when these two are multiplied, this is plus x of t minus t naught and x of t plus tau minus t naught. Okay, so these two terms are called Rx tau, and this term write as can be written as this is t cancels, so tau minus t naught, and this is also minus. So when we take the difference, you will get Rx of tau plus t naught. Okay, delay is capital T naught actually. Delay is capital T naught. I have written small t naught, but you can write capital T naught in the end. Now, when you take the subtract between these two, you will get Rx of tau. So, if you add this, you will get 2 times Rx of tau minus Rx of tau minus t naught minus of Rx of tau plus t naught. This is your output auto correlation. Now answer this one. Yes, you have 53 seconds left. Last 20 seconds. Yes, time up. So here in this question, it is said that yes, D and B, your guys are getting B. Okay. So what happening here? A 1 megahertz sinusoidal carrier is amplitude modulated by a symmetrical square wave of periodic 100 microsecond. So we have a periodic square wave which modulates the carrier. So if you are having message signal which is having the time period 100, okay. So how can you draw? That is the symmetrical square wave. So let's draw the square wave. Suppose I am drawing this type of square. What are the properties of this square wave? This is a half wave symmetry. Does it follow? Or hidden symmetry it follows? It follows the hidden symmetry. Yes, so this is the periodic signal. This is our message signal which is given in this question. The message signal is a periodic with the time period of 100 microsecond. So let's take the time period is T naught. Okay. So if I calculate it, trigonometric Fourier series, so A naught is 2 upon time period integration over the time period and the signal, message signal itself and dt. You can also write 2 upon time period minus T naught by 2 to T naught by 2. Let's take the amplitude is 1 and dt. Actually, it is minus T naught by 4 to T naught by 4. So this is minus T naught by 4 to T naught by 5. The amplitude is 1. So it is 1. Okay, because when you integrate it, after integrating, we will get T and T naught by 2 and this 2 by T naught will get cancelled. Now, if I calculate AN, this is 2 upon time period, integration over the time period and message signal and then cos. So this is 2 upon time period integration from minus T naught by 4 to T naught by 4 and this message signal is 1 and cos n omega naught T. So we will have 2 upon time period and then sine n omega naught T divided by n omega naught. So limit is from minus T naught by 4 to T naught by 4. So when we put it omega naught into 2 pi, 2 omega naught into T naught is 2 pi, so this is 1 upon n pi. And when we put this one, this is sine T naught by 4 when we put, okay, this is n into omega naught into T naught by 4. So it is n into 2 pi by 4, so n pi by 2. So this is n pi by 2, 2 times. Okay, so this is the value of an. Now, how will you write the trigonometric Fourier series? The trigonometric Fourier series for the message signal which is periodic in nature, a naught by 2, that means 1 by 2 plus summation n equal to 1 to infinity, and we have got 2 upon n pi into sine n omega naught n pi by 2 n pi by 2 and then cos n omega naught t. Okay, so if I expand it, I am getting 1 upon 2 plus 2 upon pi is common. And if I put n equal to 1, I will get sine pi by 2, which is 1. And I am putting n equal to 1, so cos omega naught t. When I put n equal to 2, it is sine pi, which is 0. When I put n equal to 3, it is sine 3 pi by 2, which is minus 1. So we will get cos 3 omega naught t, and n is also 3 here. So we will put again then 5 omega naught t, 4 में 0 हो जाएगा, okay, and then 5 and so on. So what you observe from here, odd harmonics, okay, odd harmonics. So what is the fundamental frequency? The fundamental frequency is 1 upon time period. So 1 upon 100 into 10 to the power minus 6. So this is 10 raised to power 4. So that is 10 kilohertz. So this is the fundamental frequency. Now the carrier frequency is 1 megahertz, that is 1000 kilohertz. Okay, now the sidebands that it will generate is Fc plus Fm plus minus Fm or plus minus F naught. So 1000 plus 10 and plus minus 10, so we can write 1010 and 990 you will get. Okay, so this is 2 Fc plus minus what? Harmonics of the message signal you are getting. So this is 2 F naught. Sorry, 3 F naught, because 2 F naught you will not get. So 1000 plus minus 3 F naught means 3 into F naught, that is 30. So 1030 you will get and 970 you will get. All are in kilohertz. So you are getting 990, 1010 and etc. So the even harmonics you are not getting. So you are not getting the 1020. 1020 you are not getting. 990 you got. 990 you got. Okay. 110, 1010 you got. 1030 also you got. So 1020 you are not getting. Clear? Is it clear, Akila? Coming to the next question, guys. Uh, this one. Let's solve this one first. We will take that question later on. Yes, last 13 seconds. So what are the answer? A. Okay, A you are getting right. That's correct. See, if you convert it, because it is asking that there is an amplitude modulated signal, and for demodulating the signal using envelope detector. So for proper demodulation, okay, for proper demodulation using envelope detector, for demodulation using envelope detector, the modulation index should be less than 1. Now, in the given question, this is AC cos omega CT. If I take common, then it is 1 plus 2 into cos omega nt. So, 2 upon AC in fact. So, the modulation index here is 2 upon AC. So, 2 upon AC should be less than 1. So, AC should be greater than 2. AC should be greater than 2. So, we want to calculate the minimum value of AC. So, the minimum value of AC is 2. The minimum value of AC is 2. Guys, so if you have not downloaded the BYJU'S exam prep app, then just download it now, because in the app you are going to get the leaderboard facility where you can see that how the students are participating in the quiz sessions and how you can see yourself in the top 5, top 10 rank. Okay, now solve this one. Last 49 seconds. Okay, now let's solve this one. So as you can see that the modulation index, it is asking for the modulation index. Okay, so you can write S of t, the standard expression we get from this expression, na? AC 1 plus MA cos omega mt cos omega ct. Okay, so it is 5. When we open it, actually, when we open it, okay, when we open it, we get AC cos omega ct plus AC MA upon 2 cos A plus B omega C plus omega mt and AC MA by 2 cos omega C minus omega. So if you compare this, here you can see this is the different amplitude. So you are getting AC equal to 20. But these two are having the same amplitude. That means it is AC MA by 2 equal to 5. So MA is equal to 10 upon AC and AC is 20. So you are getting 1 by 2. So the modulation index is 0.5. That is the answer. Now solve this one. Come on, now solve this one. Come on guys, quickly. Okay, so what is the answer you are getting, guys? So in this 3 minute also you could not solve. Yes, answer you are getting is D. D is the right answer. Yes, Akila, that's correct. Perfect. So here, how can you solve it? You have to calculate the maximum frequency and the phase deviation. So if your signal is S of t equal cos of 2 pi in bracket 2 into 10 to the power 6 t and plus 30 sine 150 plus 30 sine 150t plus 40 cos 150t. Okay, so this is the value which is given. Now, if you want to calculate the maximum frequency deviation, so delta f is given by 1 upon 2 pi d phi by dt. Okay, so this is 1 upon 2 pi. What is d phi? The phi is the 2 pi into phi. This 2 pi is also multiplied with the whole term. This is phi. So 30 sine 150t plus 40 cos 150t. Now this 2 pi and 2 pi will get cancelled and we will get 30 into 150 cos 150t minus 40 into 150 sine 150t. Okay, so here this is the frequency deviation and the maximum value 50 into 150, then 7500 you will get, that means 7.5 kilohertz. Now we want to calculate the maximum phase deviation. So maximum phase deviation is nothing but the maximum value of phase. So 2 pi and 30 sine 150t plus 40 cos 150t. So the maximum value of phase is root over 30 square plus 40 square, that is 2 pi into 50. So it is 100 pi. So 100 pi. Yes. Option D. Option D is the right answer. Correct. Now you solve this one. I'm giving you the 2 minutes time for this question. Yes, so what is the answer? B? Yes, exactly. The right answer for this question is B. Here we know that the frequency deviation in such type of question, okay, the frequency deviation in such type of question where the modulation index and the frequency are multiplied is actually given by the beta 1 into f1 plus beta 2 into f2. So beta 1 is 5, f1 is 1500 and beta 2 is 7.5 and it is 1000. Frequency is 1000. So it is 7500 plus 7500 and it is 15 kilohertz. This is the maximum frequency deviation and the modulation index is maximum frequency deviation divided by massive signal frequency. So it is 15 divided by 1500. 15 kilohertz divided by 1500 you will get 10. So answer is 10. Okay, now answer this one. Last 50 seconds, guys. In this question, a super heterodyne receiver operates in the frequency range of 58 megahertz to 68 megahertz. The intermediate frequency FIF and the local oscillator frequency FLO are chosen such that FIF is less than FLO. It is required that the image frequency fall outside the 68 megahertz band. What is the minimum intermediate frequency? Okay, so now here it is saying that we are interested in falling that image frequency should be outside the band. So image frequency should be outside the band. That means image frequency should be greater than 68 megahertz. So what is the image frequency? The image frequency is the radio frequency minus 2 into plus 2 into intermediate frequency that should be greater than 68 megahertz. What is the radio frequency? It is 58 megahertz plus 2 into intermediate frequency which is required to calculate in megahertz. It is 68 megahertz. So from here if you calculate the intermediate frequency is greater than 5 megahertz. So what is the minimum value it is asking? The minimum value is 5 megahertz. So answer is 5. Next question. For a super heterodyne receiver, the intermediate frequency is 15 megahertz and the local oscillator is 3.5 gigahertz. If the frequency of the received signal is greater than the local oscillator frequency, then the image frequency. Okay, so let's calculate the answer for this question. And we want to calculate that here it is given the received signal frequency is greater than the local oscillator frequency. So if this is the case, the local oscillator frequency is given as the radio frequency minus intermediate frequency. So here the local oscillator frequency is 3500 megahertz. The radio frequency we don't know. The intermediate frequency is 15 megahertz. So from here you will get the radio frequency as 3515 megahertz. And the image frequency is radio frequency plus 2 into intermediate frequency, plus or minus? Yes, it is minus because it is less than condition. So here it is less because the condition given is the local oscillator frequency is less. Whenever it is less, there is a minus sign in between them. So this is 3515 minus 2 into intermediate frequency, which is 15. So when you will subtract 30, it is 3485 megahertz. That is the answer. Okay. Now solve this one. This is a good question. So try to solve it. This x of t has been repeated. So ignore this. Okay, this is repeated. So here you can see that consider a sample signal y of t. A signal is given which is y of t, x of t here also given, and ts is 100 microseconds. Then yt is passed through an ideal low pass filter with a cutoff frequency of 5 kilohertz. So the signal which will be less than 5 kilohertz will pass. So you can see that all the options are having the 5 kilohertz less than frequency. Okay, so all the signals are having the frequency which are less than 5. Now, whenever we sample any signal, we get the signal which is 1 upon Ts, that is the time period, and summation of the signal itself, that is suppose y of t you are sampling, so y of f minus nfs. Okay, so here this is the term, and 1 upon Ts is also multiplied. So 1 upon Ts means 1 upon 100 into 10 raised to power minus 6, and here it is 5 into 10 raised to power minus 6, and x of t which is 10 into cos 8 pi into 10 to the power 3. This is the frequency which is less than 5. Other than that, we will get NFS. That means you will get around 10 kilohertz. So it is shifted to 10 kilohertz. So 10 plus 4 and 10 minus 4. So it is 6 and 14 you will get. 10 plus minus 4. So 6 and 14. So the cutoff frequency of the low pass filter is 5. So both the frequencies are greater than 5. So it will not pass. So other multiples of Fs will not pass. Only the fundamental term will come. That is your y of f for n equal to 0. So now if you will solve it, then you will see that this 10 to the power minus 6 will get cancelled and you will get 5 into 10 to the power minus 1 cos of 8 pi into 10 to the power 3. So this will be our answer, that is option number C. Okay. Now solve this. That's what you are getting now. Last 27 seconds. Yes. Yes, so if you will solve this problem, then we know that whenever we pass whenever we sample any signal and pass it through the low pass filter, so when we sample the signal, there are multiple frequencies generated, and these frequencies are the message signal frequency F naught, and then in n into Fs plus minus F naught. Okay, so this is the signal which is 12 kilohertz frequency. So it will pass, and because of this 50 microsecond, it is 50 into 10 to the power minus 6 inverse. That means 10 raised to power 6 upon 50. So it is in kilohertz. This is 1000 upon 50 kilohertz. So this will be coming as 20 kilohertz. Okay, so we will get 20 Fs plus minus F naught, which is 12. So 20 minus 12, uh, n is actually 1. So we will get 20 plus minus 12, which is 8 and 32. Okay, and then 40 plus minus 12. So we will get even more, that is 28 and 52. So the low pass filter is having the cutoff frequency 15. So the frequency component which are less than 15 will pass. So less than 15 is 12 and 8. These two frequency we are getting. So 12 and 8. So answer is option D. Okay. Answer is option D. Here. So guys, don't forget to join my Telegram group. Okay, this is the Telegram group where I am going to share the PDF. So join the Telegram group and just tag me if you want this PDF. And tomorrow at 5:30, sorry, 5 p.m. itself actually. Tomorrow at 5 p.m. Okay, tomorrow at 5 p.m. we are having the remaining questions of ISC. Okay, remaining questions of ISC. So don't forget to join this session at 5 p.m. If you are watching it later on, then don't forget to join this session because this session is going to be a very important session for all of you because actually the digital communication part is still left. As you can see that I have all solved the previous questions of amplitude modulation, random process, random variable, and also separator and receiver and angle modulation. But still, the questions from the PCM and band pass modulation and information theory, coding, noise, all these questions are left. And these questions we are going to discuss tomorrow at 5 p.m. So tomorrow is going to be a more important session than this because generally the student finds easy in the analog communication, but the students find more difficulty solving in the problem of digital communication. So that we will discuss tomorrow at 5 p.m. and that will be around 1.5 hour session where we discuss all the remaining problems of the digital communication and the communication. And thank you for watching this. Don't miss the class tomorrow at 5 p.m. So this is BYJU'S exam prep app. So don't forget to download because day after tomorrow means day after tomorrow 5:30. That is your 14th of September. Okay, that is your 14th of September. I am going to have the quiz session right on the BYJU'S exam prep app. This is on the app. This is free for all of you. They're free for all of you. So don't miss this class and don't forget to download the Bachelor's Exam Prep app because when you download it, it is going to give us, free content. A lot of contents are there for free to all of you. Okay. So anything, if anything, would you like to ask? Anything which you like to ask? ठीक है आप बताओ अगर आपको कुछ भी पूछना हो related to your preparation then you can ask. Okay, thank you. Random process and digital communication feeling difficult. Okay, so there are free sessions I am going to take very soon. So don't worry about that. Okay, don't worry about that. Free session I am going to take on the app as well as on the YouTube. So on the basis of that, you can understand the behavior of so don't worry about that. I will teach the communication part through the questions. I'm going to bring the question series for the communication and EMFT and signals and system, so those question series will help you. Yes, thank you, Banu. So let's meet in the next session, guys. Thank you.